All right, we are ready now for notes 5.3, medians and altitudes. We just talked about perpendicular bisectors and angle bisectors. Now there's two more. Dealing with a triangle. The median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. There are three of them. Every triangle has three medians, and the medians are concurrent. Well, this first median, I'll do it in blue, goes from vertex C to midpoint. Notice these tick marks. If I find the midpoint of the other side, right there, so that's equal to that, and I connect it to the vertex B. I also have a third one. So the midpoint is over here, so 3 tick marks there, 3 tick marks there. And I know it goes through that point, and that point right there, they will always come together. That point is defined on the next page. The point of concurrency of the medians of a triangle is the centroid. Another vocabulary word. The centroid is always inside the triangle. The centroid is also called the center of gravity because it is the point where a triangular region will balance. If you take a triangle, put it up on your finger, put your finger right where the centroid is, that triangle will balance on top of your finger. Below is the theorem, 531, the centroid theorem. Kind of an interesting theorem here. The centroid of a triangle is located 2/3. You have to remember that fraction. 2/3 of the distance from each vertex to the midpoint of the opposite side. So, I'll use blue here. From point A, this distance from there to the centroid is 2/3, and the leftover distance from P to Y would be 1/3. So in other words, if this distance were 6, this little distance would be 3. It's always half. So the whole distance is 9. You see, 2/3 of 9 is 6, and then 1/3 of 9 is the 3. So 2/3 and 1/3. With that said, let's do a problem. In triangle LMN, RL is 21 and SQ is 4. Find LS. Well, R to L is 21. I don't need this information. I don't care what SQ is. It's 4. I need to find LS. Well, L to S is the 2/3 part. So what's 2/3 times 21? Well, I know that 1/3 of 21, that's the same thing as 21 divided by 3. That's 7. So 2/3 has to be 14. So from L to S is 14. From S to R would be 7. So my answer is the 14. Well, let me go. I'm going to change colors to green here. And let's talk about this SQ is 4. So I'm going to put SQ is 4. So if SQ is 4, then looking at the diagram from S up to N would be 8. The whole length would be 12. So I just kind of added that on. I think that's the... Getting ahead of myself here. That's the next page. Find NQ. If SQ, let me write this again. SQ is 4. SN is 8. To get from N to Q, I would have to add those together. Thanks. To get a final answer of 12. Sorry, I got ahead of myself there on that page. Let's move on to the 5th slide. In triangle JKL, ZW is 7. So Z to W is 7. Let's mark that. And LX is 8.1. So from L to X, that's 8.1. Find KW. Well, if this length from W to Z is 7, that means from Z onto K would be twice it, 14. Twice 7 is 14. That means from K to W, I would have to take the 7 plus the 14 and get an answer of 21. So 21 would be my answer. So wait, I didn't have to use this 8.1 yet. That comes up on the next slide. Find LZ. That's what I'm trying to find this time. LZ, if LX, so from L to X is 8.1, LZ would be 2/3 of that. So with the calculator, just take 2/3 and multiply it by 8.1, whatever that would be. Just use your calculator. Well, if I want to keep going, what would ZX be? Find ZX, that's the 1/3 part. So to find that one, you would just take 1/3 times 8.1. Again, use your calculator. The next slide talks about a new definition. This is the fourth one. We've talked about perpendicular bisectors. Then we talked about angle bisectors. And then medians. This is a new one. Fourth one. Fourth word, altitude. An altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. Every triangle has 3 altitudes because they have 3 vertices. An altitude can be inside, outside, or on the triangle. Next slide. In triangle QRS, altitude QY is inside the triangle. Look at your diagram down there. But segment RX and SZ are not. Notice that the lines containing the altitudes are concurrent at P, point P. This point of concurrency is called, new vocab word, the orthocenter. And there's not a lot of information about the orthocenter, but we can draw it. Find the orthocenter of triangle XYZ with vertices given, and I have the triangle drawn for you. Remember, it goes from a vertex to the opposite side at a right angle. So if I go here, start up way up top at Y. If I drop a perpendicular in, be like right in there somewhere. And I go from over to the left, angle X. If I drop the perpendicular, be like right there. And the fourth one, of course, would be from Z, and that would be a perpendicular. Notice that they all are concurrent right in there. It looks like it's about over 5 up, maybe 1.5, I would say. It could even be about 5.5, 1.5. So again, when you freehand them, it's not as accurate. So to review, median, they intersect at the centroid. Altitudes intersect at the orthocenter. And then don't forget with medians, you have that 2/3, 1/3 thing. That's all I have. Thank you for watching.